Sharon, Esther, Favor, and Eric were told to share 40 mangoes. You love mangoes, I know you do. Now, Sharon got 10, Esther got 10, Favor got 5. Now, let me ask you, how many will Eric have? I know you already know the answer. Now, the answer is 15, right? Now, how did we get that? Very simple. Just subtract the sum of the mangoes others got from the total sum they were to share. Wow, this is interesting, right? Now, this method can be applied in calculating the oxidation number of an element in a compound too. All you have to do is to subtract the sum of the oxidation numbers of all other atoms from the algebraic sum. Isn't that simple? Yes, it is. Now, let's take an example. Now, what is the oxidation number of iron, that is Fe, sulfur, S, and nitrogen N in the following compounds or radicals? FeO, H2SO4, and NO3 minus. Let us calculate for FeO. Now, we have Fe plus the open bracket minus 2, close the bracket, equals 0. Now, what do? We open the bracket by multiplying the plus times minus, and we know that plus times minus will give us minus. So we have Fe minus 2 equals 0. So what do? Simple, right? We collect the like terms. Now, Fe equals 0 plus 2, and Fe equals 2, because we know that 0 plus 2 gives us 2. So that means our oxidation number for Fe in FeO is plus 2. Moving on, so we know that the oxidation number of iron is plus 2. Now let us take a look at H2SO4. We have plus 1 times 2, right? Because the number of hydrogen here is 2. Now, plus, you close the bracket, plus sulfur, S, because we don't have business with sulfur. Now, plus open bracket minus 2 times 4, close the bracket, equals 0. So we have our equation at this point. Now, moving on, what do? Now, we say plus 1 times 2, that is what? Plus 2. Plus sulfur, that is S, plus 8, because minus times plus gives us minus. Therefore, we have minus 8. You close the bracket and it gives us 0. Now, S equals 8 minus 2, and S equals 6. Now, how did I get 8 minus 2? I collected the like terms. Moving on, we know from our calculation that the oxidation number of sulfur is plus 6. Now let's look at our third example, NO3 minus. We have N plus open bracket minus 2 times 3, close bracket, equals minus 1. So simple, right? Now let's solve further. N, that is nitrogen. Now minus 2 times 3 will give you what? Minus 6, because minus times plus equals minus. So we have N minus 6. Now don't forget, when you do minus 2 times minus 2 times plus 3, that is minus 6, right? We also have a plus sign outside the bracket. So what do? So the plus sign that is outside multiplied by the minus 6 you got inside. So plus times minus 6 still gives us minus 6, because we know that plus times minus or minus times plus gives us minus. So we have N minus 6 equals minus 1. That is the minus 1 on the other side of the equality sign. So what do? Very simple. Now we collect the like terms. It means we bring numbers together and alphabets together. So we have N equals minus 1 plus 6. Don't forget that when the minus sign crosses the equality sign, it becomes plus. So we have minus 1 plus 6. And what is minus 1 plus 6? That is 5. We have plus 5. So the oxidation number of nitrogen is plus 5. So the oxidation number of nitrogen is plus 5, as I said earlier. That's interesting, right? So what have we learned today? We have learned that the oxidation number of an element in a compound or complex ion is obtained by subtracting the sum of the oxidation numbers of other atoms from the algebraic sum. Wow, that was insightful, right? I hope you enjoyed that class. See you in the next class. Bye for now.